Hello, my name is Peter Mitev and I'll be doing a short presentation today on the latest developments of VRayRT running on GPUs. Today is 14th of May 2010 and obviously any information provided will be valid as of today. So in 2009 at SIGGRAPH in the United States we showed a research that showed how we can run V-Ray shaders on GPUs, so we got quite a boost there. And the thing is that today we are actually showing VRayRT, which is practically a completed product running on GPUs. So today I'm going to use 3ds Max interface, but we will have the same solution available for Maya probably in the next 2 months. So the first thing we really have to understand is that VRayRT, and VRayRT running on GPUs are three completely different products. But unlike the competitors, these three products actually manage to shade and light the same and in the same way. This is extremely important for production pipelines where you do not want to redo your shaders, redo your materials, or you don't want to export a lot of your data in other applications because that will actually waste a lot of time. With V-Ray you can fluently switch the three rendering solutions on the fly and you don't have to worry about not being able to render the same materials because VRayRT as well as VRayRT running on GPUs will render the same result seamlessly without you having to worry about your setups. So that's very important. So V-Ray is a full-blown production rendering tool that you would find in 3ds Max as well as Maya available. So if we hit render here, we will get the production renderer working on this setup. And what we can see is 6 cores rendering this scene. So the reason we see 12 buckets is because we actually have hyperthreading enabled. So that doesn't really bring too much into the rendering power. So all in all, we have 6 physical cores rendering at this moment. So as I said, VRayRT will follow all the settings of V-Ray. So all I need to do to switch to VRayRT is to make sure that we have VRayRT enabled here in the active shader. Switch to the active shader and fire it. So right now we have VRayRT running on CPUs. And we can see that we get the interactive setup. So all I need to do is just change anything in the scene and then VRayRT will instantly follow all of my changes. So I can change my shaders, all of my setups, and I'm not going to go into any more details because we already have presentations on this on YouTube, so you can check that out there. So what I want to emphasize on is the speed. So currently we have around 635,000 kpads, that is ray traces per second. So this kind of gives us an idea about the performance of the particular system that I'm using. So right now I'm using all in all about 20 gigahertz render power to render this image out. So, as I said in the beginning, VRayRT and VRayRT on GPUs will follow the same setup and they will be able to render the same shaders in the same way. So you don't have to break your pipeline and you don't have to quit using your old material libraries with V-Ray. Okay, so I will close this down now. And I will close my rendering engine running in the background and I will start the GPU-based rendering tool. That's all I did. Obviously, in the final version of V-Ray, you will not have to do this. It will be simply an option in a drop-down menu somewhere in 3ds Max. So let's see how that changed our rendering speed. In the beginning, we will need to wait a few seconds for the scene to be transferred to the GPUs and for all the materials to be compiled to run on the GPU. So there is a longer initial phase in the beginning. Okay, this is the feedback that we get from the GPUs. And if you take a look here, instead of having a number of 500 or 600, I have 10,000, over 10,000 kpads, which are ray traces per second. This actually means that we have about a boost of 20 times with the GPUs. So probably the first question that would pop up in your mind is what kind of GPUs I'm using at the moment. So these are the new GTX 480 graphics cards from NVIDIA. I'm actually using 3 of them at this particular moment. So These graphics cards are considered to be more of a gaming cards rather than production cards, so we are waiting for the new solutions coming from NVIDIA in the next few months with the new Tesla and the new Quadro boards. Okay, so important thing to notice is that we still get the same interactivity. We don't lose that with the GPU. And you can see the kind of quick refinement that we get. I can also set up my shaders, so if I open my truck shader here, I can still change the colors, and the GPUs will be able to catch that up and render it in real time. So that is quite a boost, right? So let's try to open a different scene that gives us even more information on how the GPU solution works in VRayRT. So if we take a look, we will see that we have about 4.7 million polygons in this scene. So in the same way, now I will switch back to my software renderer so that we can compare the speed of my system running on CPUs and afterwards running on GPUs. So this is quite a resolution. So right now we are going through that initial process where V-Ray has to prepare the scene and start rendering it. So with the CPU solutions, this is quite faster, and it's kind of slower on the GPU, so that's sort of a limitation there. So we'll need to wait for a few more seconds for V-Ray to be able to calculate this number here, and we'll take a look at it. Okay, so this is after waiting for over a minute, and this is the kind of feedback that I get from my CPUs, which are in total about 20 gigahertz render power. Okay, let's close this down and start the GPU version of RT. So right now, as I mentioned, we'll have to wait a little longer for the scene to prepare, so I'll pause the recording. Okay, and if we take a look at the same number here, we will see that instead of having 150,000, we have over 150,000 ray traces. We have over 6 million ray traces. So this is actually about 6,066,000 ray tracers. So the kind of performance boost that we just got with V-Ray running on GPUs was definitely over 20 times. It's actually more close to 40. Okay, so that's kind of the performance boost that we get with the new GTX graphics cards, and this resolution that we're rendering at the moment is about 1200 by 500 or so. So as you can see, it's fairly easy to use the V-Ray line of products because we don't force you to change your shading and lighting setups. All you need to do is just change the rendering engine, and you will get instantly this kind of boost within your system. So this solution will also be available for Maya in the near future. So let's open up a different scene. And I want to show you that at this moment we are not really dependent on the graphics cards to hold our video, which means that we can render practically any resolution that can fit into our 3ds Max interface, and we don't care about that even if we use the graphics cards. So let's take a look at the setup here. I'll directly use the RT. So right now we are using this resolution here. So if we take a look at the number here, we see that we are rendering currently at about 400,000 pads per second. So again, I'll just switch to my GPU solution. Obviously, in the final version of VRayRT, it will be simply a drop-down menu. Okay, so instead of having a number of 450, we are running at over 10,000 here. So as you can see, the feedback is a lot faster. We still get the same interaction. We don't lose that. And you can see how easily you can use the VRay line of products to seamlessly switch between the production renderer, the RT, and the RT running on GPUs. So, as I said, we are not restricted by the resolution. So what I'll go and do now is I'll increase my resolution to something like this. And I'll re-render the same scene. So right now we are using the GPUs. And you can see that even at the resolution like this, the GPUs are running fine with VRayRT. Okay, so obviously everybody would ask what sorts of limitations do we have with the graphics cards. So the limitations that we are running into are in one way or another restricted by the amount of graphics board memory that you would have installed. So in general, one wouldn't think that they would be able to render on a computer that has, for example, 20 gigabytes of memory. They wouldn't expect to render the same stuff on a graphics board that has only 1.5 gigabytes of memory. And because at this point we cannot swap in and out data from the graphics cards to the hard disk and vice versa, the moment we hit the memory limit, that's when we actually stop the rendering process. And that's a limitation in terms of the amount of polygons you can squeeze in, as well as the amount of textures and the size of textures one can use with the VRayRT running on GPUs. But this is not a limitation of VRayRT, it is a limitation of the graphics boards. Another great thing about VRayRT running on GPUs is the fact that we are actually using OpenCL. We do not use CUDA. And that's in a way great because even though today there is only a single hardware provider that supports OpenCL properly on the GPUs, in the future you will be able to use other graphics boards as well the moment they're available if they support properly OpenCL. So that's kind of great because we don't restrict you to use graphics cards provided by a single supplier. You can rather choose between different brands and different graphics boards in the future. Okay, so thank you very much for watching this presentation. Stay tuned for more presentations as they become available in the next few weeks. And stay tuned so that you would know when this excellent solution will hit the market. Thank you.